Can you able to
Sir.
see screen?
Sir.
Yeah. So temperature effects on diode operation. So if you increase the temperature, what
Sir.
will happen? Hello. Yeah.
Sir, download option இல்ல சார் அங்க எப்படி சார் டவுன்லோட் பண்றது?
Download option இல்லையா?
Yes sir. லிங்க்குள்ள போனா தான் வருது தவிர டவுன்லோட் ஆப்ஷன் இல்ல சார்.
I will see that one. Okay. So let's I will see. But you can able to view right directly. You can change the slide and all.
Yes.
Okay, I will see download is possible or not. I will see.
Okay sir.
Okay. So can you able to see the screen? Temperature effect on diode operation. Yeah. So here one graph is there. What is that graph? I think you know it. What is the graph?
So temperature.
Already we discussed this. It's a forward bias characteristics, man. Yeah. So based on the voltage. So based upon the forward voltage VF, what is the current flow? So that is plotting in the y-axis. So in x-axis, I am just representing the voltage, and in y-axis, I am representing the current. Okay. So now what will happen in the temperature? So if the temperature increases, so if the temperature increases, what will happen? Due to increase in temperature, this thermal activity will decrease the diode resistance. So decrease the diode resistance means it will make the electron to come out. The temperature which you are applying, or it may cause due to the flow of electrons. You know it, right? See, if you are using any resistor, just take a resistor. Now don't consider about the semiconductor. If you take any resistor, if you're applying a voltage and current will pass through the resistor, it will dissipate or not? Hello?
Yes sir.
Anyone? Yeah, it will dissipate, right?
Yes,
You
sir.
can able to observe. You can able to observe using the charger wherever the power device are available. Charger, the laptop chargers. You can able to you can able to observe that heat will be dissipated. So energy is converting, and it will dissipate in form of heat. So due to that heat, in a conductor, if the heat is increases in the sense, the resistance will increase. So current flow will decrease. This will occur in conductor. But in a semiconductor, due to the thermal activity, the resistance will become decrease. Once the resistance decrease means what will happen automatically? The current flow will increase or not? Whether current flow will increase or decrease if resistance is decreases?
Sir, increases sir.
Increases. So surely it will increase the flow of current. So that is what happening in the semiconductor. So here, if you look at these characteristics, at 25 degrees Celsius, I am giving very less temperature at 25 degrees Celsius. One diode will having the cutoff voltage. So cutoff voltage, or it is called as a threshold voltage. I will write in a. So it is called as a cutoff voltage or threshold voltage. So threshold voltage is represented as VT. So minimum required voltage to conduct the diode properly. Okay. So after that, it is increasing the current very drastically. So at 25 degrees Celsius. If you go 100 degrees Celsius, how the semiconductor will sense? Even we know that for a diode cutoff is 0.7. Some may vary at 0.6. Due to this change in temperature, now what is happening actually? Less than 7, it is start. I mean, the current flow will start to increases. So this is what by fixing this one. If you go for this one, so I am fixing the current So when I'm achieving the 8 milliamps, so when I'm matching the 8 milliamps at 25 degrees Celsius, at what voltage? I'm matching at more than 7. And similarly, I'm calculating at 100 degrees Celsius in a diode. If the temperature is 100 degrees Celsius, at what voltage I'm achieving 8 milliamps? At what voltage I'm getting? At 0.7. If you go for this one, V1, it is very greater. If you go for the V2, which is having 100 degrees Celsius temperatures, and I'm getting at 0.7. So I can fix with the voltage. I will fix the voltage at 0.7. What is the current rating for 25 degrees Celsius and 100 degrees Celsius? Now I am fixing 0.7 at constant voltage. Now what is the current flow? So this is your current flow occurring at 25 degrees Celsius, approximately 2 milliamps. And similarly, at 0.7 voltage, I'm checking the current flow during 100 degrees Celsius. So that is nothing but 8 milliamps. I can go by keeping the constant as a voltage and calculating the current. Otherwise, I can keep the current as constant and I will take the voltage. What is the corresponding voltage? So what is the effect of temperature? If temperature rises, automatically the resistance becomes decreases. So if resistance decreases, the current flow I become increases. So this is the concept for your semiconductor. So conductor is quite different and semiconductor is quite different. And it will be applicable for both the forward bias as well as the reverse bias condition. Now we will see in the forward bias. Let check the statements what they given. So an increase in temperature means increase in thermal activity and decrease in diode resistance. And as temperature increases at a fixed value of Vx, the IF increases. Surely you know that if I'm keeping the voltage, the current become more higher. And here in second statement, I'm keeping current as fixed value and I'm checking the voltage. Voltage is decreases or increases? See, if I'm keeping the 8 milliamps as a constant and during 25 degrees Celsius, the voltage is higher and during 100 degrees Celsius, the voltage is lesser. So that's why they represent VF is decreasing. If I'm keeping the VF as a constant, IF is increasing. Okay, so this is the effect of temperature during forward bias. If you go to the reverse bias condition, so the same thing will occur. Let's see here in reverse bias condition at 25 degrees Celsius, what is the current maximum? What is the current maximum I'm getting? Anyone tell? What is the current I'm getting? I'm achieving. Anyone? Guys, are you there?
Yes, sir.
Yeah. At 25 degrees Celsius, what is the current flow? See, current is clearly representing here in y-axis. Yeah. So 5 microamps, right? 5 microamps in reverse bias condition, current will be very less. It will be in a range of microamps. In a forward, it will be in milliamps. That is fixed one. Okay. And if I'm increasing the temperature to 35 degrees Celsius, now the current is increased to 10 microamps. Similarly, if I keep on increasing at 45 degrees Celsius, due to free electrons, I'm getting 20 microamps. So in a forward bias, as well as the reverse bias, if temperature increases, surely the current is increases and the resistance is decreases. So this is the effect of temperature on the diode. Okay. All of you clear about this topic?
Yes, sir.
So this is they will ask from PN junction diode. So what is the effect of temperature for the PN junction diode? So on the time you have to draw this graph and you have to explain what is happening likewise. And today we will see another topic, rectifier. Already I discussed about the rectifier. What is rectifier? Basil?
Converts AC to DC.
Sorry, sir.
So what is the rectifier? Yeah.
The convention of alternate current to direct current, sir.
So alternate current is nothing is converting into direct current. So that is nothing but the rectifier. And I told about the application, whether this is application for a PN junction or Zener diode. The rectifier is
PN junction, sir.
PN junction. So good. And for Zener, the application is regulator. So regulator is used to control the output. It will give you a constant voltage. So that is a regulator. Rectifier is converting the AC to DC. Okay. So here two types of rectifier is there. One is a half wave rectifier and another one is a full wave rectifier. So let's see what is the half wave rectifier. Can you able to see the PPT, ma? All of you?
Yes, sir.
Yes, sir.
Yeah. So just a definition they given. So rectifier rectifies that circuit that converts the AC to DC. And can you able to tell any example? Converting AC into DC you are using day-to-day life.
Battery.
Battery, chargers, mobile chargers, laptop chargers, the converters and inverters. So inverters is doing what action actually? So inverters, what it is doing from the battery, is applied to your home appliance. So it is doing quite opposite action, like DC to AC. Yeah, so DC to AC. Rectifier will do the operation of AC to DC. So alternating current, you know, like a sine wave, it will be available, and DC direct current will be a straight line. So there is no frequency, right? So what is the frequency for DC? DC frequency? Can anyone tell?
Sir.
DC frequency.
DC frequency. Zero. Sir.
Zero. So there is
Zero
no frequency.
Hertz,
Zero. So there is no frequency. So we will represent there is no oscillations occur in the DC. Just a straight line. Okay. So okay, now you can able to see the diagram clearly. Can you able to see, ma? All of you? Diagram is clear.
Yes, sir.
Yeah. Okay. So off-wave rectifier. So in an off-wave rectifier, I will use only one diode. And why it is named as off-wave rectifier in the sense, you know that alternating current having the positive off cycle as well as negative off cycle, right? One complete cycle consists of positive cycle as well as negative cycle. In this off-wave rectifier, I can able to take the positive cycles only. Not only positive cycle, any one of the cycle. And another cycle will be suppressed or discard. I will remove it. So that's why it's named as off-wave rectifier. So here, look at the definition. The process of removing one of the input signal to establish a DC level. So it's called off-wave rectifier. So here they are presenting only one cycle I am taking, another cycle I am discarding, removing or suppressing, whatever may be. And you can able to see that it's not a DC, right? Can you able to see the waveform?
Yes, sir.
Yeah. So it is look like the DC or what?
DC, sir.
DC. Is it? Does it look like DC?
1 minute, sir.
1 minute. Does it look like DC? Just a question. Guys, does that look like DC?
No, sir. It's AC.
AC. So AC in the sense alternating current, whether it is alternating from positive to negative. Let me explain. See, so this is the AC signal. Okay, so this is your AC signal, which is having the positive as well as negative. Again, it's come back to your positive, likewise it keep on going. So it's a periodic signal. So periodic signal is nothing but the signal that will repeats for particular duration of time. If you consider from this point to this point, the same will be applicable for from here to the next complete cycle. Okay, and if you see this output, this is your current as well as this is your voltage, the second one. Okay, check the voltage here. It is taking only the positive of cycle, but negative is not available. I told that yeah, off-wave rectifier, if you given a AC signal like this, you may get only one cycle. The remaining will be suppressed. Okay, and this signal is called as pulsating DC. It's not a pure DC. It's a pulsating DC. So pulse are available, but still it's a direct current. Why? Because it is having only in one direction, only the positive. You can anyone see the waveform of your direct current? It will be like this. So if, wait, I will write. So it will be like this. So in a graph, suppose the voltage having the 5 volt in distance, it look like a straight line. There is no oscillations. If it is a negative 5 in the sense, it will be like this, -5. This is the origin 0. Here this is the origin 0. So with respect to the time, I'm calculating the voltage. Okay, so it will be like straight line. It's not like this, like having an oscillation from here to here. So this is called as pulsating DC. Okay. Now come to the definitions. In off-wave rectifier, the rectifier conducts current during only positive off cycle of the input AC signal only. Negative off cycle is suppressed. Okay. Let's see the operation of this diagram. What is the first thing? I'm applying the AC supply. AC supply. What is the voltage level? In your home appliances, what is the voltage? AC voltage?
220.
220, 230 actually. So you may get 230 volt, and you can able to see the specification 230 volt, 50 hertz frequency. Okay. Can you able to give this directly to your charger? Is not possible, right? Why?
Yes, sir.
Because this voltage is very high, as well as it is a AC voltage. So first thing is I'm going to step down it. So for step down, I'm using the transformer. So transformer, what it I'm using this and step down transformer I'm using. So this 230 volt AC will convert into 5 or 12, whatever maybe, the based upon the step down secondary winding. If secondary winding is more, means it will be like a 12 volt, 24 volt. If secondary winding is less, you may get 5 volt. Okay, first step is I'm just step downing. That's why I'm using the transformer. Why? Because the diode is used for low voltage purpose, not for high voltage purpose. Okay, so that's why I'm using the transformer. And next, I'm giving the diode. So what is the diode operation? Now tell me. What is the diode operation?
Sir, it allows current to flow in one direction. Sir.
So current will allow only in one direction, not in opposite direction, right?
Yes.
Yeah.
Yes, sir.
I will erase everything so that I can able to draw again. Okay, so it will allow the current to only one direction. You see here, here I am connecting here, and the signal will be like this. Still it is AC, which is having less magnitude. So magnitude in the sense only the RMS value will be there around 10 voltage likewise. So here it is 230 volt, here RMS value will be 10. Okay, and I am giving this to your diode, and you can able to see this is your anode or cathode, this terminal. Anode or cathode. So this is anode and this is your cathode. Can you able to see what I'm drawing? Everyone?
Yes, sir.
Yes,
Yeah.
sir.
So I'm giving a first consider the voltage is 0 and slowly it is increasing 0.1, 2, 3, 4. For example, keep the maximum voltage as 5 volt. So it will increase from 0 to 5 volt. On that time, you know that I'm giving the positive here. Here it will be the positive value, and the cathode is connecting from here, means so it will be at negative. So this is in forward bias or negative reverse bias? Forward or reverse? Anode is positive and cathode is negative. Forward or reverse?
Reverse.
Forward. So during forward, the current flow will occur. So you can able to see the current are occurring as it is, and similarly the voltage also same. So there is no change. It will act as a resistor. So resistor, what is having actually? It is having some resistance value, and the current flow will occur, and voltage also will be available, right? So it will act as a resistor during the positive off cycle. If you are giving a negative, if the cycle turns into negative, so what is happening here? It will be -1, -2, -3, likewise. So in this, it is here. Now during the negative off cycle, so during the negative off cycle, what will happen? So I am giving them -1, -2. So here it will be minus, and here it will be plus. Now it is a forward or a reverse bias condition. Is it forward or reverse bias condition? Ma, this is anode, ma. Anode is negative, cathode is positive. Is it forward or reverse bias condition? Guys, yes, can you hear me? Anyone answer? Is it forward or reverse? Is it reverse bias, right?
Yes.
Yes. Ma, you people are sleeping, all of you. Anyone respond?
No, sir.
For this, you are responding. While asking question, nobody is answering for me. So during reverse bias, is there a conduction will occur or what?
Sir, will occur, sir.
Conduction won't occur. Only forward bias conduction will occur. Current flow will occur. In reverse bias, there is no conduction. It will act as an insulator. So it will act as an insulator in the sense open circuit. Okay. So forward bias means closed circuit, closed switch, or closed resistance, and reverse bias means open switch. Is it clear, all of you?
Yes.
Yeah. So in negative, due to open, there is no conduction. So current is 0 as well as voltage is 0. Because I am taking the voltage from here to here. So this is how the half wave rectifier are working. Okay. All of you clear the operation? Do you want me to explain again?
Sir, one more time, sir.
One more time. Just clearly listen. So AC supply I'm giving, having a high voltage. After that, I'm using the step down transformer to convert the 230 voltage to your 12 volt or 5 volt or 10 volt based upon what we require. Okay. After that, I'm connecting the diode here. In a diode, you know that diode operation is will conduct in only one direction. That is from anode to cathode. Okay. And in reverse bias condition, no current flow will occur. It will act as an insulator, open circuit. Just consider forward bias means closed switch, reverse bias means open switch. It will be open. So you are giving the AC signal which is having the positive as well as the negative. Okay. So during the positive off cycle, the anode may appear the positive and the cathode will be have negative voltage. So that the diode will start to conduct. So conduction, during conduction, I told that it will act as a switch. So how the circuit will be like this, I will draw here. This is your resistor and this is another resistor, and here I am giving the input signal. So this is nothing but the diode. In forward condition, it will act as a resistor, or I can able to resistor in the sense this is a practical one, but ideally it is nothing but a closed switch. Okay, so if switch it closed means what will happen? Current flow will occur. The voltage will also be there. If you take in the output voltage across the resistor, so that during positive off cycle, A is connected to positive and cathode is connected to the negative. It is in forward bias condition, so the conduction is occurring. So you are getting the whatever the input signal I'm giving. I told that it will act as a switch. So whatever the input you are giving, output you may get the same. Once it going to the negative, on the time the anode become the negative and cathode become positive. It represents reverse bias, RB. So during reverse bias, the switch will act as open, OPEN. And similarly, it will be, there is no connection occurring from A to B. So what will happen? There is no voltage will be there and there is no current flow will be there. So it becomes 0 here. Clear? Huh? During positive cycle, it is doing the conduction. So I am getting whatever the input. V0 is equal to Vi. During negative, V0 output is equal to 0. Why? Because the diode is in reverse bias condition. It will act as a insulator, or I can tell it as a open circuit. Okay, so no conduction is occurring. So this is how the functioning. Clear, all of you?
Okay, sir.
Yes, sir.
So yeah, they given what are the things I explained same I'm given in terms of the definitions. The AC voltage across the secondary terminal AB changes its polarity after each cycle. So changes its polarity in the sense that they are telling the positive, negative. And second point, during negative off cycle, the terminal A is in negative, so diode is in reverse bias and no conduction. So the current flow through the diode during positive off cycle only. So in this way, current flow through the load resistance RL in only one direction. So that's why you're getting this only on of positive cycle. Suppose if I connected the diode in this direction, I will draw here. I am connecting in this direction. Here the load RL will be there. And here it's a secondary winding. Okay. So if I connect it here, I'm giving the same as it is. I'm giving the positive off cycle and negative off cycle. What will be your output? Can anyone tell what will be your output? What will be your output? So during positive, and this is anode and this is cathode. So during positive, here it will be minus, sorry, here it will be plus and here it will be minus. So it's a forward or reverse bias. Is it forward or reverse bias?
Yes.
Reverse bias. So during the reverse bias, there is no conduction. So
No
it will be 0. And during the negative,
Forward.
here it will be minus and here it become plus. So on the time forward bias. So I am conducting the negative off cycle. So this is how the graph will occur. So during this position, you're getting the positive cycle. And during this position, if the diode connected in reverse direction, you may get the only negative signal, not the positive off cycle. Okay. So on the time, you may get the negative DC voltage. So during this, you're getting the positive DC voltage. During this, you're getting the negative DC voltage. So that is the difference. So here they given the disadvantages. Just I told the pulsating current in output contains the AC component whose frequency is equal to supply frequency. So filtering is needed. So listen here. If you go back here, the current is like this. So it is keep on still oscillating. Surely you have to apply to the filter. So filter is nothing but I will use the capacitor. So what is define capacitor? Anyone? Define capacitor. Define capacitor.
Sir, to store an electric charge.
Store the electric charge. Okay. So in order to do the filter operation, I want to connect the capacitor after the diode so that I can able to get the pure DC. I will tell how it is, how you will get the pure DC. Okay. So let's see the second disadvantage. The AC supply delivers power during off cycle only, so output is low. So see here, I am giving the full cycle. One is positive and another is negative. I am getting only one off, so the power would be half of the power I am getting. So output is very low when compared to your input. So these are the drawback for your off-wave rectifier. Okay. And now we will see the filter operation. If I connected the capacitor, what will happen? Okay. So you know that this is your output from the diode, right? Is it right? All of you? So after the diode, I'm connecting one capacitor. So let's see what is happening here. So this is the circuit actually. This is your output I'm getting, and this is your input I'm giving. Okay. So anode, cathode. Listen. So during positive off cycle, just consider this off quarter cycle. This is actually a full cycle from here to here, and this is the off cycle, and this is a quarter cycle. So during this, I am giving the positive voltage. So in this time period, the capacitor will start to charge. Okay. So initially it is in zero condition, and I'm just telling that it is providing a 5 voltage. Okay. So during from here to maximum Vmax, the capacitor will start to charge. Now it is having a 5 voltage of your AC. Okay. Once here, what is happening after that? It is dropping to 4.9, 4.8 up to 4.0. So during this condition, the capacitor will discharge and it will deliver the additional voltage. So due to delivering the voltage from the capacitor, it will maintain the same value. So here I will draw the output. So once it is starting at maximum, after that, the capacitor will start to discharge. It will provide the value which is stored to your output so that it will maintain the constant, and slowly it will start to drop down. Why? Because it won't maintain maximum 5 voltage always. Surely there will be a drop. You can able to see overall using the LED TVs. Once you switch off, you can able to observe that the LED will goes off for fraction of second. It won't go immediately. Is it right? Is
Yes,
it right?
sir.
Yeah. So thing
Yes,
is,
sir.
instead we having the capacitor, so it will deliver it will discharge the voltage so that it will maintain the some voltage. Again, what is happening in this condition? Here again during this off cycle, the capacitor will start to charge. So that's why again it will maintain the value. Again it will drop. So almost it look like the DC circuit. So that is the purpose of your capacitor. It will do the filter operation. Filter operation in the sense it will block the AC, allow the DC. That is the operation. Okay. So here they're calculating the frequency of output. You can able to see one complete cycle consists of positive as well as the negative. This is your input, and output is also a positive will be there and a 0 voltage. Again for next cycle, again one positive and then 0. So this is your one cycle having same frequency. So F0 is equal to Fin. Okay, clear about this output frequency?
Yes, sir.
Now we will go for the full wave rectifier. During half wave rectifier, I used only one diode, and I convert alternating current to your only a one pulse, half of the pulse. And in full wave rectifier, I'm going to use two diode. One is in one direction, another is in reverse direction, so that I can able to convert a positive off cycle as well as negative off cycle. So that is a full wave rectifier operation. Let's see the definitions. In a full wave rectifier, current flow through the load in same direction for both off cycle of the input. So if you are using full wave, every signal, the positive as well as negative, will come to your positive. Okay, so that is the advantage of your full wave rectifier. Here I am using the two diodes for working in alternative way for positive as well as negative to convert. Why? Because one diode will suppress the negative, means another diode will allow the negative. So likewise, I will work with two diodes. Okay, let's see the operation here. So this is your transformer. This is a special type of sound transformer which is having a center tap. I think you studied about the transformer, right? Guys, types of transformer you studied.
Yes, sir.
Yes.
So center type is a special type of transformer. For full wave rectifier, surely I want to use the center tap transformer. Okay, and you can able to see there are two diodes. One is a D1 and another one is your D2 diode. Okay, and load I am taking from here to this is your output. V out I am connecting to your ground. Okay, so this is where I am taking the output. And let's see the operation how it is transforming. Okay, so during the positive off cycle, as we know that the center tap, here it will become positive and here it will become negative. Okay, and similarly, and in this condition it will be a negative and it will be a positive. So that is the thing of a center tap here. You can, so here it's okay. So if you take here while positive off cycle, D1 will be conductive. Is it right or not? D1 will be conductive, so that I am getting the output voltage from the D1. And during positive cycle, you can able to observe D2 is in forward bias or reverse bias. D1 is in forward bias, means D2 will be in reverse bias. Okay, why? Because here anode is connected to plus, cathode is connected to negative. Similarly here the anode is connected to the negative and cathode is connected to positive. So this is in reverse bias condition, no conduction will occur. And if you go for the negative of cycle, due to change in polarity, the plus positive at the cathode will become minus, and here minus will become plus. And similarly, in this condition, this will become plus and this will become minus. So due to this, the D2 will start to conduct because it is available in forward bias, and D1 is in reverse bias condition, so it won't conduct during negative off cycle. So that's why you are getting the D2 value in positive cycle. So thing is, the D2 will shift the negative value to the positive value. So that's why we are using the center tap transformer. We can't able to do the operation using the normal transformer. In center tap only, due to this two additional point, two different voltage I can able to give. Here it will be positive, means here it will be negative. Here if it is negative, means it will become positive. So that is the purpose of your center tap transformer. Okay, so let me clear, nothing, just like a diode only. So if you're giving a positive, D1 will conduct, I'm getting the output voltage. If I'm giving the negative voltage, D2 will conduct, so that I'm getting the voltage at D2 because of D2. So this is how the full wave rectifier are working. Now let me clear about the off wave and full wave.
Yeah, clear, sir.
Let me clear.
Yes, sir.
Yes, sir.
Any doubt, guys? Off wave and full wave rectifier. Is there any doubt?
No, sir.
It's okay. Let's take the attendance. Sixteen student came. Abhinav absent still. Syed Mohammed, Veeramanikandan, both are absent for all classes.
Sudeep Alex.
Sudeep Alex, you told, and Vikash won't come.
Seva Perumal.
Seva Perumal, I think he came. Let me check the timing. Wait.
Sir, he said that he is facing some problem in Hattabili, sir. Sevaka Perumal.
Okay.
Sevaka Perumal, sir. For past 1 week, he said so, sir.
I will check. Wait. Anand, why did you join at 1:30?
Sir, some net problem, sir.
Net problem. Simply telling some net problem. Huh? Now it become common for all. Okay. So answer attendance, Sriraj,
Sir,
Azad, Azad, are you there?
hello.
Yeah. Jyotish. Jyotish.
Yes, sir.
Nitish.
Yes, sir. Present, sir. Sir, Basil present.
Okay. Emmanuel.
Yes, sir, President. Yes, sir.
Uday Kumar.
Yes, sir.
Madhuban.
Yes, sir.
Okay. Aditya.
Yes, sir.
Yeah. So you will tell only for attendance. If I ask any question, you won't open your mouth. Right? Aditya?
No, sir.
Arun Kumar?
Present, sir.
Vinit?
Present, sir.
Amala?
Present, sir.
Nitin?
Present, sir.
Basil? Basil Saji?
Present, sir. Present, sir.
Louis?
Present, sir.
Anand? Okay.
Sir.
So totally 15%.
Sir,
Yeah.
how many students are present, sir?
15 total.
Actually, 16 members present, sir.
16. Then who is that? Veeramanikandan.
Yes, sir.
Veeramanikandan. When did he
Veeramanikandan is present,
When
sir.
did he join? Wait. It's not showing his name. Wait a second. I will check it again.
Sir, Arun Kumar present, sir.
Uday, okay. Veeramanikandan.
Present, sir.
When did you join, ma? At 1:54. Veeramanikanthan, come out and talk.
Sir.
When did you join? Joined at 1:54. That is the time to join in class.
Sorry, sir.
I can't provide attendance for you. Only 15 students present.
Okay, sir.
Okay. Next class, join in time hereafter. Don't tell silly excuses. It's okay, all of you guys. You can leave them. I will end the session. If any doubts, you can ask now.
No, sir. Thank you, sir. Sure, sir.
Okay.